Well, actually a couple days have gone by since the last moment in this video, and I took yesterday off and I worked, well, you saw the first part of this video I did a couple days ago. In the meantime, I've come in and done some experimenting in here with an OA3 tube here. And in the course of doing those experiments, I got more interested in the operation, or the misoperation of the eye tube, which is really what we're going to focus on. So I've attached this wire to the triode plate pin inside the tube here. We'll just wrap the wire around one of the pins and push the tube in, so I could see the voltage of the triode plate, and therefore the voltage of the deflector, and see what's happening with it. Because the way the eye is operating is, it appears to be indicating a high strength signal all the time. The pie is closed, and then as you do bring in a signal, it overlaps a wee bit. So what really should be happening is, when there's no signal, the pie should be opened, and that should be because the deflector, which is sitting I guess about here, something like that, if you kind of get me, if you know something about these tubes, the deflector is always at the plate potential of the triode. And so with that kind of potential, it's as if it's not there. It's as if it's invisible. So the electron rays just go straight along. When the signal goes away in the radio, the deflector should become very negative relative to the plate, and that should start pushing the beam away like this. So the question would be, why is the deflector not falling in voltage? Why is it staying so high close to the plate voltage? And that would suggest there's something going on with the grid of the triode. And I haven't done any testing to check that. Now, we're going to look at the schematic, but I'm pretty sure the grid of the triode in here is connected just directly to the same grid wire, AVC distribution wire, as all the other tubes. So whatever's happening with this tube is happening with the other tubes. That would be a bad thing. So it's not making sense to me. Let's put it that way. This isn't adding up or making sense. So let's take a look at the schematic and see if we can reason something out here. Okay, so here's the eye. Here's the grid connection. If we follow it up, it's just a wire going to the, I'm going to call the AVC distribution wire. It's on the high impedance side of this resistor. How can the grid of this tube be at any voltage different from the grids of all the rest of these tubes up here? They're all hooked up to this grid wire. This one's got more isolation. Excuse me. That looks like it, actually. So, well, that is it. That's the first tube. Another isolation here. 500,000 ohms. Straight to this guy. So conceivably, whatever's happening here must be happening pretty much exactly the same way on this tube. Well, I don't know. So getting access to these wires is not so easy. Because the tube is up on top of the set, and the wires that run underneath, their colors are all shot. So I'm trying to trace exactly which wire is this. It would be easier to come back from here, from this point actually, point D. I want to find this point. Well, actually, finding this is easier. This is really easy. I should come this way, find this point, put a voltmeter on here, and watch what happens. Okay, that's the plan. Okay, it took a bit of time, but I found that resistor hiding from view, from my view, underneath this yellow wire. So I've connected to one end of it with this clip lead ready for voltage measurement. But first, I think reading its resistance might be a good idea. I'll find out if it still is 2.2. Picofarads. Well, it is in the circuit here. And there are capacitors around it. That didn't help much. That almost suggests it might be open. If it were open, hey, you know what? If it were open, that would mean the radio never receives an AVC voltage. Or just always has a basic bias, I guess, all the way through it. That's not possible. Haven't I watched the AVC go up and down on another meter? Let's try this. This one here is supposed to be 2.2 million. So lots of snow on the ground outside now. Up to 20 centimeters falling today. That's a fair bit of snow, and it makes my house, anybody's house, really bright. Even though the sun is behind clouds and it's actually a dark day, it certainly isn't dark, because once the snow falls, it's as bright as can be. The light comes in your windows not only from the sky downward, but it comes in from the ground upward, shines on your ceilings, really lights a house up in the winter. So that's kind of an odd situation. If you don't live in a wintry country, it's not dark here in the winter, as long as there's snow on the ground. There we are. Now what do you say about this? So there's the capacitor charging. 2.7. It's just a resistor. Let me change it. Since we're having trouble in this circuit, I'm going to pop it out of here. Where'd it go? Hey, where'd you go? You just kind of disappeared. Ah. Son of a gun. Where did it go? It made a break for it. Oh, there it is. Way out here. Okay, let's test it out here now. It's definitely red, red, green. 2.2 megohms. So it's gone high, not too surprising. Would that really make a difference in this radio? 2.2 versus 2.7 in this position? Probably not. That'd be my guess. The radio could work quite fine with the 2.7, but I'm going to put a 2.2 in there because, maybe I'm wrong. I'll put that in. Okay, down there is the new resistor, 2.2 for sure. Now, that's just not going to make any difference in the operation of the radio, I'm pretty sure. But then again, what I'm pretty sure about, me being sure doesn't mean anything in reality. Don't tell my wife I just said that. But let's find out what reality says here. So I'm going to clip on to the AVC circuit here. This is past the 2.2 resistor. We'll hook it up to the meter when the time comes. Time does not come. I'm going to take a moment and just clean up my bench here. I got too much stuff laying around. Okay, I think we're all set here. So I've got the radio tuned on shortwave. I've got the signal generator connected to the antenna. Signal generator is running at 11.8. Radio's tuned to 11.8, or it was. And I've got this meter over here, almost ready to watch the AVC voltage, which will be on the end of this red wire. And over here in this block of cement is a wire sticking out. This shows the triode plate and deflector voltage. The two of them being essentially the same thing inside this tube. Maybe I shouldn't say same thing. Okay, same voltage. We're all set here. Volume down and radio on. Here we go. Watching the dim bulbs because they did something in there. No problem. All is good. Give it the full enchilada. Lots of volume in this radio now, that's for sure. Okay, don't hear the tone of my signal generator. There it is. Very weak. Very weak. Why so weak? Here we go again with the weakness. So, the signal generator level is set. Well, I'm going to check its calibration. We got to check it and see. Okay, it's low. 10 times 100 is 1,000 microvolts on the antenna, and we can not hear it very well. Should be able to hear that really well. Maybe this weakness is more extensive than I realized in this radio. I thought it was just on the broadcast band, then I convinced myself, no, it's okay. Now I'm being convinced it's weak on the that's really, really weak. Well, okay, one thing at a time. Let's carry on with what we're intent on doing. Okay, now, first thing is, does hooking this up make any difference to the radio? So listening. Adds a touch of noise. Very hard to hear though. Okay, and watching the meter now. Joe's not watching. This is a pretty low voltage. Negative voltage, Jim. So there's the AVC voltage. On the 15 volt scale, that's about 9 volts. I'll tune the radio and watch the operation of the AVC voltage. See if it makes sense. So I expect this to go up as high as even 20 volts. It's at 9 volts with a powerful signal on the antenna. Something is really not right here. Oh. Now as for the eye operation, why? So this much variation in the grid voltage of the eye, assuming that this is exactly what was going on. I think we can actually look at the eye and see this. Yes, 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 yes. Look upon the eye. So it's as if the AVC voltage is just too negative. No, not negative enough. Right now it should be much more negative, and that would cause that pi to open. It's kind of a weird thing. What would cause that? We don't need to listen to all this noise. So if we switch the meter now to look at the plate voltage. So let's think about this. First of all, gotta go up, gotta go positive. Let me disconnect over here. So let's watch this now. Just clipping on here. Oh, you're still watching the eye. It's not doing anything to the eye. A little bit, not much. Okay, other camera so you can watch the meter here. You know what, I'm going to stop. I can get both these on the screen at the same time through the power of modern video technology. That would be modern household video technology. Okay, we can see a couple things happening now. So the meter is hooked up. This is the plate voltage. Let's tune in and out. We'll watch the eye and the voltage. So at this point, no signal, the plate voltage should be dropping way down, very low. That makes the deflector very negative. It means the electrons coming at the deflector get deflected and make that pi whoosh, as it goes through. It's not much of a pi, so this can't have much significant voltage on it. And instead of being all the way down to 0, it's still up at 110. With no signal. Is it every band like this? No. What did I just do now? So I flipped it to, this is the highest band. Look at the pi. The pi has opened. The pi has opened. Not here. Not here. Okay, so let's start here. This is the push button settings I haven't done anything with. This is broadcast band. This is the next band. This is the one that we're fooling with, but right now it's tuned into something, isn't it? No, it isn't. This is the one we've been tuned on. Wow, okay, that really paints an unusual picture to me. Wow, okay, this is some information here to chew on a bit. Let's switch back to the AVC voltage monitoring here. And take that off there. Okay, we're back on AVC. And we'll just switch the meter here to negative and low. Okay, we'll do the band thing again. So here we are. Notice too, the band is very quiet. Quiet band. Quiet band, no output from the IF. No output from the IF, no generation of an AVC voltage. No generation of an AVC voltage. We change bands. It can go all the way. All the way. So this is starting all the way. This is the 1316 meter band. Next band. That's a better comparison there. The noise difference here. Hard to interpret this exactly. Let's keep going. Next band. It's just... Is this band even receiving? What's happening? Okay, so this is push button, broadcast, shortwave, 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 shortwave. So as a story here, we've got a couple bands working really quite normally and a couple not. Is that really what we've got? So I need to put a signal into this radio on this band. And we're way up on the high band now, and we're roughly in the middle. Way up on the high band, roughly in the middle. So, really, are we really on the highest band? Yeah, so we're on the 16 to 13. And we're tuned right around in here, so around 19. So I'm going to feed a 19 megahertz signal in there. I can't do too much here, too many things to try to get on camera at once. 13. Is that what I said? 19. How did it turn into 13? Okay, we're going up on a fairly strong signal. Let's get a little more volume on the deal here. 16, 17, 18, there was 19. Sounded pretty good to me. Look at that, look at the eye. So there's no problem with the eye circuit. There's something weird going on with a couple of bands. This one's working beautifully, in fact. Okay, so this top band's good. Next band's going to be similar, I think. So now we're on, where are we now? So we're on the 19 meter band, and we'd be tuned around 15.25. Just a quick check of the radio sensitivity and everything. 15.25. 16.7. This is probably the image. I think it's just better off watching the meter here. That's where the action is. Okay, going down to 15.8. What's the eye? The eye is behaving perfectly. Wow. Well, this highlights why my experiments I was doing, which I have not explained, and I will not explain right now, failed because the radio was not behaving. If I switched it up onto this band and done my experiments, I would have got a sensible result. Hey, wait a minute. We've got more bands to check. So the two highest bands appear to be working normally. Let's go another band here. Okay. The radio sounds a lot more sensitive. All this crazy noise. The noise could be generating that voltage. Okay, and the band we're on now, 11. And we're right in this area, 11.8. Roughly 11.8. 11.8. Okay, that's 12.7, so that's the image. Okay, don't know what this is. That's at 12.15. Don't know what that is. There's 11.8. You can see on the meter it does not drop all the way down. Next band is quiet again. I notice the ABC voltage stays up. And this band, it's just reassurance everything's working. 9.7, 9.625. 9.625. That's 10.5, so there's the image. there's that. That's 9.9. What the heck is that? And there we are. So it has the same problem as the other band. The sensitivity doesn't seem to be all that bad or anything. So we'll go down to the B band now. Okay, notice the ADC really dropped off here. And on this band, we're around 5 megahertz. Okay, heading for 5 megahertz. I'm going to come from above. Okay. Because I want to hear the image if it exists. So coming down. No image. Something right there. Very weak. 5.3. 5. Is that it? Oh no, here we are. 4.4. What's that eye doing? Overlaps. Okay. And this is the AM band, just for the sake of completing everything. So in this case, we will be tuned around 1150. 1150, eh? First, let's go see if we can see the image. 1150, the image would be 12, just under 12. No, under 1150, under 2. So I just went right through the where the image would be. Depends where the local oscillator is, if it's above or below. Okay, coming down towards where the radio is actually tuned. Hello. Once again, I'm not going to get it at 11. It should be around, say, 1200. Not a thing. Not a thing. If I got this right. Yes, it's on broadcast. Okay, giving it the works here from my signal generator. This is all mysterious to me. 1 million. Did I just do this terribly wrong when I held this up here? Maybe I did. We're more in this range, so that's around 1 million. Okay, here we are. Look at that AVC voltage. What's that eye doing? It's way over closed. Okay, so what this means is it's really easy to figure out which band is doing what by simply watching this meter and switching through them. You can tell the whole deal here. Let's go push buttons. Well, you don't know what's going on with the push buttons yet. AM. There's the voltage that shouldn't be there. Next band's okay. Next band, there it is. It's exactly the same again. Next band, not so okay. Then we got the 2 top bands that seem to be working just fine. Broadcast band. Oh, that's like exactly the same voltage. Coincidence? Human beings do not handle coincidence well. Now let me watch the eye while I'm doing this, because I was not. Okay, so that's push button, AM. It's an easy thing to make an observation of. This would be the B band, 31 meter band, 25 meter band, 19. See, there's a little extra there too. It's just like if you get to the higher bands, whatever the problem is, it can't manifest itself as well. this band. It seems to be different than the rest. And this would be the 31 meter band, so I think. Just be sure. B band. It's the B band. Okay, so I'm going to stop and think about what I've just seen. How can these bands be behaving so differently? That's a good question, and think about how to pursue this further. Try to get to the source of what's happening here. Okay, so just in thinking about this a little bit, so what we're measuring here with this meter is basically the output of the IF. The more signal coming out of the IF, the more of it gets rectified, the more of it pushes on this meter. So we could think that what's happening is on certain bands there's a lot more coming out of the IF than other bands. And in fact we hear noise. When we turn to those bands we hear noise, as if they are for some reason much more sensitive. Noise wouldn't normally push a meter up too high, but it's going to rectify the noise, and it's going to produce some amount of AVC signal. But when I change bands, nothing in the IF is changing. There's no capacitors going in. There's nothing going on. The IF is just sitting there doing its thing, trying to process a 455 kilohertz signal that it's being presented with. It's the presentation that must be changing. It must be in the front end of the radio. There, as you change bands, you change all kinds of components. Capacitors, you're switching in and out coils, you're doing lots of stuff, presenting different signals to the IF. So I think whatever it is, assuming again it's a problem, I think it's a problem, has to be something to do with the front end of the radio. Now, why not take a look on the oscilloscope and see what we can see from what we can see here. Well, one reason for not doing this is the oscilloscope is going to load down the circuit. So how much is it going to load it down? Now, we don't have to look at the AVC meter because we're looking at the I. The I is an AVC meter. It's just not calibrated. But we can see relatively what's happening with the AVC voltage. So first I'm going to remove the meter. That's me hitting, you can practically see what I'm doing somehow through that camera shot. Not doing much. Okay, now if I hook up the, I'm on the times 1, maybe that's a little bit of a problem. Well, that's interesting because this was having a big effect a moment ago. Yeah. Okay, let me put it on here. Oh, you know why? Look what I'm doing. What a dummy! I'm touching it not to the radio. I'm touching it to the meter here. Okay, look, radio. Yeah, see, it's just draining out the AVC voltage. That's surprising, isn't it? The scope would have a lower impedance. The scope input impedance is 1 megohm, and my meter is 10. The resistor I put in there was 2.2. So you can just figure 2.2 add 10, or you use 10, and not much effect. Use 1, lots of effect. Let me put this on times 10 and see if that helps somewhat. Okay, so we'll do that. Times 10. We want to look at the shape of the signal anyway. Not really interested in its level. Let me just put this up a little bit towards the center. Make it a little more sensitive, a little more. Let me put it on AC. We're interested in what's going on here. So now we're going to switch bands and watch what happens here. Signal generator is still running, but it's down on the broadcast band frequency. So we'll shoot down here. This is push button, and the eye is open. The eye is closed, and there's not much of a signal there, is there? That's back to push button. Broadcast. B band. Well, whatever it is that you can see in there, it's getting worse. It's not getting better. That's probably just a little hum from the power supply. Oh! Okay, we hit gold here. Some kind of a ramp-shaped signal coming out of the... Oh! What happened there? I didn't even move. Help me. Quickly, where's the coffee? How did that happen? There we are again. Is it from touching that knob? Is it from touching the knob? But it didn't seem to affect the eye at all. And what does this sound like? Sounds like that. Well, it looks like it has something to do with that wave we can see here. And the two top bands, eye wide open. No weird wave. Come down one band, down another band, another band. Jesus, it's something getting right into the radio from my shop. I discovered how sensitive the radio was to just waving a coiler. Where'd that signal go? I just waved my hand here and it disappeared. But the eye stayed exactly the same. Come on! Whoops, I disconnected the scope. Okay, scope's back on. So if it were some kind of oscillation that's occurring that we can't hear, we can't even realize it's there except it's doing this AVC voltage thing, then you would expect when it disappears, like it appears to have disappeared now, it appears to have disappeared, the eye would relax, but it's not. This is not helping a lot. So there's something funny there bopping around. I think you can still see it there. Okay, we're down to the push buttons. You can see the scope recentering because the DC voltage is so different from here to here. That's what's making that eye operate. Where's this voltage coming from? There's a difference in the sound here, right? Hey, what was that? There it is again. Why, like what the heck? Looks like something similar to that. Let me trigger my scope on 60 cycles. If I can, I think it'll work on that. Come on, scope, trigger for me. It just does not want to trigger. Well, too bad for you. So what kind of frequency would that be? I think it's in the range of a hum. You know what, I was going to put in additional filter capacitors anyway. Maybe now's the time to do that and just eliminate that as a possibility, although I have no idea how hum in a power supply could be causing this kind of thing. It doesn't add up in my head at all. But then again, once again, what's adding up or not adding up in my head does not necessarily force reality. That's for sure. Okay, so I think I just decided to do something. Oh yeah, put in those capacitors. That's what I'll do. We'll do that stuff. I got to do it sooner or later anyway. Do it now. Do it now. Okay, what we're gonna try and do now is watch the signal that's going into, or look at the signal that's going into the IF. This is a bit of a long shot for me. Using the SDR in the lower right. And you can see the pickup coil here. I've just stuck it around this metal tube because it's in the right area. This is the first IF can. It's kind of in the right area. We'll start there and just see what shows up. Now, the radio's off at the moment, so I'm going to switch it to the broadcast band to start with. And I'm really not sure what's going to happen here, but we'll just go through the bands and see. Often what happens is you end up seeing stuff you never expected. That's kind of where we're at. Here we go with the radio. Let's see what develops here. Turn the volume up a little bit. Oh, that was more than a little bit. Okay, so the local oscillator is showing up there very strong. I was wondering if the local oscillator strength is varying, and that is really what is at the root of this. Yeah. So tune the radio a little bit, see what moves. Just the local oscillator. The other things you see moving on the SDR are, I don't know, to be ignored. Okay, but in this mode, the eye is closed. I'm going to switch to push button. The local oscillator just disappears entirely, so there's a problem with the push button circuitry, which we have to deal with yet. Okay, so I'm going to go up to the next band, which is band B. Okay, the eye opened a bit. What is this that just showed up? Just tune this a little bit. Well, wow, it's just zooming. What is that? So I'm tuned to around on band B. I'm around 5 megahertz. So the thing that's down here, it's either an artifact of the SDR or something else. What we need to do is we need to go up to around 5 here. Okay, now that's probably the local oscillator there. We tune the radio, we should see it. Yeah, it seems correct to me. See something down. Oops. See something down yonder here. I think it's to be ignored. And this signal at 48, solid as can be, sitting there. No idea what that would be. It's right in the. It's something local in my shop or my house or something. It's so solid, or it's an artifact of the SDR. Well, the eye is hardly open. Nothing unusual here. The thing is, my SDR is only showing about well, not quite 2 megahertz of the spectrum. Something could be going on way outside of this. Let's go up to where, oh, okay, I'm tuning along here. Why is the eye behaving like that? What's happening now? I'm on the B band. Is that right? Let me be absolutely sure. Yeah, B band. Signal generator is running at about 1 megahertz. We shouldn't see anything here. The radio certainly is picking up a strong signal. Sure sounds like my signal generator. So I'm going to reach over and retune the signal generator a bit. What this is telling me is, if you're operating this radio and you're tuned to where it's tuned right now, somewhere around 5 megahertz on the B band, that a 1 megahertz signal on the antenna will come out the speaker. That doesn't sound very good. This really opens up a whole kettle of fish. Kettle of fish? Kettle of fish? There it is again. So I've tuned the radio now to another spot on this band. Oh my gosh. So I think I've gone down a bit. So I'm down around 4 megahertz. And again, I'm picking up the 1 megahertz signal. And I'm admittedly pounding that into the radio. Let me reduce the pounding. You know, it's still there. It's down in the range of reasonable signals from an antenna, and you can hear it. Oh my gosh, what is going on here? There's a whole world of these radios I've never explored very thoroughly, and I think I'm about to, which is, in the case of my SDR radio, I've become well aware that you can tune in stuff that doesn't exist at that frequency, and it happens a lot on the SDR. These radios, they could be doing the same thing for other reasons, for different reasons. Here's an example of a radio responding to 1 megahertz signal on the antenna when it's really tuned to 4 megahertz. How can I get a grip on this? This is maybe nothing to do with the ABC behavior, or maybe everything to do with it. Maybe the symptoms that we're seeing right now are symptoms of this problem that is causing a different set of symptoms in the AVC. If you can swallow all that. Because I've got too many thoughts in my head here. Too many thoughts. So all these things you see it picking up, these noise signals, are they really there at that frequency, or are they at some other frequency, like the megahertz signal? Okay, wait, let's go back to this megahertz signal. Where'd it go? And I swear I can hear that thing the whole time we're doing this, faintly in the background. Tuning doesn't seem to matter. Where'd you go, megahertz? There it is. Okay, so I'm gonna raise the signal generator frequency a little bit. It's at 983. I'm gonna raise it up to really 1,000,000. Okay, so now it's 1,000,000. Can I find it again? Yep. Oh boy. I mean, in doing all these radios I've done, how often have I looked to see if a radio picks up a frequency other than the one it's tuned to? Almost never. I don't think I've ever gone on that kind of hunt. I mean, I certainly know about the image problem. How do you end up with this kind of a situation? There has to be, like, for us to hear this, there has to be a product coming out of the first detector or the mixer tube at 455 for it to come out the speaker. Can the IF be sensitive to something other than the frequency it's tuned to? I don't think so. I don't think so, but I would think that of the radio generally. Doesn't appear to be true of the radio generally. This is a whole area here I just never really stuck my nose in. Don't know if I've ever really encountered exactly this kind of situation here. You know, I did actually with another small shortwave radio that picked up stations left and right. But the problem was half of them were not at the frequency I was picking them up at. Although it's fun to use a radio because it picked up a lot of stuff, but it's picking up the same thing again and again and again. I don't know how to explore this question, and we're kind of wandering away from the issue of the magic eye here a bit. So let's go up another band here. We got more bands to go. So here, for some reason, the eye is also closed. But we can hear it's not picking up anything but noise. So I'll leave the signal generator at a megahertz and tune the radio here. Everything seems bizarrely stable. Why is everything so bizarrely stable? Sound level's not changing. Oh, it is now. It's the end of the road. This doesn't seem right at all. This is the we're no longer on the B band. Let's just make absolutely sure. 31 meter band, 9 megahertz. We're roughly in the middle. 9.575. 9575. Okay, I'm going to wander around and just turn myself. We'll hit the radio with this. So, wow. The radio's tuned to 9.5 megahertz and it's picking up 1.1. 1.2. You know, 1 point. Yeah, I don't know. Let's just keep going up. We'll just. Oh, now it's picking it up. This is right out of the AM band. So this means if there's a noise signal at 1365, which there is noise there, this radio's going to hear it. In fact, if you got a radio, come to think of it, you got a radio that's trying to tune one frequency, but in fact is tuning 9 at the same time. That would be 9 there. It's going to get the noise from all these. If there's a signal on any one of them, you're going to hear it too. But you can get all that noise. Is that why? Is that what's going on here? So I tune to a band that's picking up 9 noise signals. And that's the whole reason. More noise coming out the IF. We hear it coming out of the radio. All because it's tuning, you know, a dozen spots at once. That's an interesting explanation for what's happening. Well, no, yeah, and right following that is, well, why? Why? Some kind of decoupling capacitor, not decoupling things? Okay, I think I'm going to end it right here because what I feel coming on is a very complicated experiment, and I think I've done enough for now. Yeah. Yeah, I sure have done enough. Oh my gosh, what a crazy situation. Never really encountered this before, but I really haven't gone fishing for it all that much. Interesting stuff. Well, thanks a lot for watching, and I'm going to ponder this today while I do other things, and then tomorrow I will try to set up some kind of grand experiment to really expose what's going on in this radio. That would be my plan. See ya.